Many banks employ traders. These traders buy and sell financial instruments. They invest some of the bank's equity and hope to make some profit for the owners. But this trading activity is risky. As we all know, market prices can go up and they can go down. In this session, we are going to describe this trading risk. It is often called market risk because it relates to prevailing market conditions. We will introduce the concept and then discuss value at risk. This is a common method for evaluating risk-taking by traders. Market risk comes from the trading book. As we have seen before, we can divide a bank up into its lending business and trading business. The lending business consists of long-term investments held in the bank book. The trading book includes long and short positions in securities, derivatives, and other financial instruments. Items held in the trading book are marked to market on a daily basis. This means that banks have to immediately recognize losses when the value of its trading positions change. Market risk captures this uncertainty. If market conditions change, prices will change, and this may impact our bank's profits and equity value. The subprime mortgage crisis of 2007 through 2009 is a classic example of losses due to market risk. Beginning in 2006, house prices in the US began to fall. Subprime borrowers, these are the borrowers with the highest default risk, well, they began to default. Many financial institutions actively traded subprime mortgages through their holdings of mortgage-backed securities, or MBS. These securities took heavy losses. To give you some context, subprime MBS losses were around $1 trillion by mid-2009. Total bank equity, this is summed across all US banks, was around $1.3 trillion before the crisis. Many banks became insolvent due to market risk exposures. You may have heard of Lehman Brothers. Back then, Lehman was a famous investment bank. Lehman declared bankruptcy on September the 15th, 2008. It rocked the financial world. Market risk played a key role in Lehman's fall. Let's take a closer look. Here is Lehman's trading portfolio in May 2008. Here we can see Lehman's holdings of MBS, $72 billion altogether. Between July 2007 and July 2008, these MBS fell in value by around 50%. That's 50. We can be generous and assume these are AAA rated securities. So, roughly speaking, that's 50% times 72, a $36 billion loss. What you can't see here is that Lehman had $26 billion of equity. This means that the mark-to-market losses in the MBS portfolio wiped out the bank's equity. This is how Lehman failed. Trading can be highly profitable, but banks understand that market risks can threaten solvency. Risk managers understand this, and they monitor traders' portfolios. They analyze market risk, and they put limits on the amount of risk that an individual trader can take on. The daily value at risk is a common measure of trading risk. It tells us how many dollars the trading portfolio will lose tomorrow under a worst-case scenario. Here is a simple example to illustrate value at risk. We have two bets. Both require a $1,000 investment. The first has a 50-50 chance of loss or profit, a $100 loss when market conditions are bad, and a $300 gain when market conditions are good. The expected return is $100. The other bet has 4 potential outcomes. Some of the probability now shows up in the tails. 10% of the time we lose $800. 10% of the time we gain $1,000. the expected return is the same. The value at risk answers the question, where are my losses in the worst case scenario? For bet 1, we can lose at most $100, and for bet 2, it's $800. So, if we are worried about the worst possible outcome, then bet 2 is riskier. Banks apply the same concept to a trading portfolio. In practice, this is very complicated. JP Morgan Chase has dozens of trading units spread across the globe. But if we can estimate how sensitive profits are to market conditions, then we can aggregate this up to the portfolio level. And under certain conditions, this will give us a nice, smooth distribution that tells us the likelihood of different profits. The value at risk answers the question, I am X% confident that profits will exceed Y dollars tomorrow. Here we have the 99% value at risk. So 99 times out of 100, the trading portfolio will have profits greater than Y dollars. Or we can say that in the 1% worst case scenario, the bank's profits will be less than Y dollars. If this potential loss is too large, then the position will be sold. One final point. Value at risk is often criticized as a measure of risk. Let me briefly explain why. In practice, return distributions are not always smooth. Under extreme market conditions, returns can be a lot worse than anticipated. These extreme events are sometimes called black swans. This corresponds to a fat tail in the return distribution. The value at risk statistic is still valid. Profits will still exceed Y dollars 99% of the time. However, if tomorrow turns out to be a bad day, the average return can be a lot worse than Y. During 2008, for many financial institutions, trading returns fell into the fat tail region of the distribution. Risk managers and regulators realized that extreme losses could far exceed the value at risk projections. Since then, new market risk models have emerged that account for this possibility. We covered 2 points in this session. We introduced the market risk concept. This is about potential trading losses. These can arrive tomorrow and can be extremely bad. We then discussed how value at risk can put a dollar value on these tail events.